Hi everyone. Is the audio clear? Okay. So now we will discuss live variable analysis. But remember this live variable analysis, or you can call it liveness analysis. Okay. Liveness analysis. This we have already discussed in the last lecture. Okay, so what we have already seen in the last lecture, that I will not discuss. I will quickly give you overview of what we have seen in the last lecture. What is this liveness analysis? Okay, and this liveness analysis, basically this is what are the applications? Can anyone tell me what are the applications? What are the applications of this liveness analysis? One is dead code elimination. Okay, so one is dead code elimination. This is one application, and then another application is a register allocation. Okay, I will tell you why. Okay, I will tell you why in register allocation we use this liveness analysis. Okay, yes, this is very important. Okay, in the GATE 2021 this question came, okay, from this topic. Okay, so you can notice this topic is added in the last year. Okay, so last year this topic got added. Okay, so you can notice what is this liveness analysis. The topic is the concept is extremely simple. Okay, just think about it and tell me. Okay, this concept is very simple. What? Okay, just think about it and tell me. Let us assume you have s equal to a plus b. Okay, and then you have s equal to c plus d. Okay, now then tell me. Okay, and then we have some statements. Now just tell me this point. Is there any can I remove this? Which statement can I remove? Just tell me this point. Okay, from this. Okay, tell me which statement can I remove? Can I remove something here? Yes, this statement I can remove, right? Yes or no? This statement can be removed. So this statement we call it dead. Okay, this statement is dead code. Why? Because we are not using it. Okay, just think about it. We are not using it. Okay, because here we are assigning a plus b to s, and now in the next statement we are assigning c plus d to s. So we are not using this assignment. So basically this assignment is not used. Yes or no? So I can say this assignment not used. This assignment is dead. I can say this assignment is not used. Is not used. So this assignment is not used. So we can just remove this assignment. Okay. Now another example. Let's see another example. Okay. So let's see another example. Let's see. For example, if you have s equal to 1, s equal to 2, s equal to 3, s equal to 4. Okay. Tell me which is dead code. Tell me which of them is dead code. Now you can notice these are the dead codes. Yes or no? These are the dead codes. Okay, again, these assignments we are not using. Now, first of all, let me tell you very important thing. Okay, in compiler design, this is very important. I want to tell you, in compiler design, whenever I say definition, okay, definition is same as assignment. Okay, that is same as modification, or I can say that is write operation. That is write operation. Okay, and you can notice use is same as read operation. Read operation. Okay, so remember, whenever I say assignment, that means definition. Whenever I say definition, that means assignment. Okay, so tell me, okay, if I give you this statement, tell me in this, okay, some statements I am giving you, and you tell me in these statements, okay, what I'm defining and what I'm using. Okay, basically remember, read operation means read operation means use. Okay, if you are using it, use means read operation. Okay, and write operation means assignment, or I can say definition. So tell me, if I give you this statement, a equal to b plus c, then tell me what is the use in s1, like what I'm using in s1 and what I'm defining in s1. Tell me what I'm using in s1 and what I'm defining in s1. Use, another word of use is reference. Another word for use is a reference. So either can call it use or reference, or you can call it read. Okay, so tell me in this statement what I'm using and what I'm defining. So in this statement I'm using b comma c, I'm defining a. In this statement, tell me what I'm using, what I'm defining. In this statement, what I'm using and what I'm defining. I'm using a comma c and I'm defining a. Okay, I'm defining a, correct? So is this clear to everyone? Okay, so for example, S3. Okay, in S3, print f a comma b comma c. Tell me what I'm using and what I'm defining. What I'm using and what I'm defining. I'm reading these things. Okay, I'm reading these things. I'm reading these things and I'm not writing anything. So, okay, so this is empty and this is A, B, C. I'm not right. I'm not changing them. Yes or no? Is this clear to everyone? Okay. So are you getting this point? So here I'm not defining anything. Okay. Use means reference. Okay. So for example, I can also say, okay, both are same thing. For example, if I give you S3, if A is less than C, go to L. Then tell me what I'm defining and what I'm using. What I'm defining? This is also called referencing. Okay, what is this? What I'm using and sorry, use what I'm using and what I'm defining in S3. So in S3 I'm not defining anything. I'm using a comma c. I'm using a comma c, correct? Yes or no? Is this clear to everyone? What I'm using, what I'm defining. I hope this is clear, correct? So use means basically the from this, okay, from this point onwards, read. Read simply means use. Use simply means reference. Okay. And write. Write means defining. Okay, define. Okay. So this is the assignment. That means assignment. Okay, now tell me. Okay, so basically here in this, actually these definitions are not used. Yes or no? These definitions not used. These definitions, these definitions, or I can say these assignments, these definitions slash assignments not used. Not used anywhere. Correct? Is this clear to everyone? So this is dead code. I hope this is clear to everyone. So basically what I mean is this. Okay, you can notice, are you using, are you going to use it? This is the point. Are you going to use it? Is the value needed? Will you use it anywhere? Okay, so will you use it? For example, if I have, okay, if I have this statement, okay, let's assume I have this statement a equal to b plus c. When will I call this statement live? When can I say that this is live? Just tell me this point. When can I say that this statement is live? I will say this statement is live. It means somewhere this A is used. Somewhere I'm using this A. Yes or no? Somewhere this A is used. Okay? Yes or no? Somewhere this definition is used. Here, this is the definition of A. You can notice here we are defining A. We are defining A, we are using B comma C, or okay, we are using B comma C. Now this assignment, this definition is somewhere used. Then we say that this statement is live. When can I say this statement is dead? This statement I will call dead. This assignment, this definition is called dead if we don't use it anywhere. If this A is not used anywhere, not used anywhere, not used anywhere. Okay, is this clear to everyone? Okay, so this is the point. Now I was telling you that liveness analysis can be used in register allocation. Why? Can anyone tell me? This is my question. Why can I use, okay, liveness analysis is can be used in register allocation? Why? Okay, so this is the question. Why liveness analysis can be used in register allocation? Anyone? Yes, very good, very good, very good. See, okay, why? Okay, let me tell you why. Okay, just think about it. If we have done liveness analysis, the answer is very simple. Okay, let us assume you have done liveness analysis. You have done liveness analysis. What it means? Okay, now what you have? Liveness analysis. What you have done? Okay, you have done. Okay, you have done. You did liveness analysis. Now what we have? Now we know at every point what is live, what is dead. Yes or no? So okay, so at every point, at every statement, we know which variable is live, which variable is dead. Yes or no? We know which variable live and which variable dead. Correct? Which variable is live, comma, which is dead. Yes or no? Now just think about it and tell me. Let us assume this is a point. At this point, let us assume this is a statement. Okay, in this statement, let us assume that these variables are live. Let us assume these variables are live. Okay, A, B, C, D, E. These variables are live. What it means? Just tell me this point. At this statement, these variables are live. What it means? It means they are used somewhere. It means somewhere you are using A, somewhere you are using the value of A, you are using the value of A, somewhere you are using the value of B, somewhere you are using the value of D. Yes or no? Correct, correct, correct. Yes or no? D, comma, E. Okay. So this is the point. Now tell me, if you know that these are the, okay. So now tell me, can I put them in the same register? Can I put them in the same register? Okay, see, at this point of time, you know they are live. You know they are live. Okay. Now my question is, because all are live, so I have to give them different register. Yes or no? Because this value will be used somewhere. This value will be used. This value will be used. Okay. All these values are going to be used. Okay. In the future program. In the future, they are going to be used. Okay. So it means these variables must be given different, these variables must be given different register. These variables should be in different register. So they should be in different register. Yes or no? They should be allocated different register. I can say allocated different register. Okay, correct or not? Now just tell me this point, very important. Tell me, if you know that variable A comma C are never live together. Okay, at, okay, there is no point. There is no point. Okay, so okay, I can say no statement where A comma C are live together. Then what can I do? Then what can I do? Then I can give, then I can allocate them same register. Yes or no? Then they can be given same register. They can be allocated same register. Yes or no? Allocated same register. Okay, so this is the idea. Okay, so you can notice one thing, you can notice that, okay, just tell me this point. When you are writing 3 address code, do you worry about how many registers are there in the machine? Okay, during 3 address code, when you are writing 3 address code, during 3 address code, okay, do we worry about how many registers we have in the machine? Okay, do we worry about? Okay, we don't worry about. Yes or no? We don't know. Okay, during the, this is intermediate code, this is the intermediate code. We don't know how many registers are there in the machine. How many registers are there in the machine? Yes or no? In the machine, target machine, correct or not? Correct. So how many registers we have in the target machine? This we don't know. Okay, so actually during this target, during this TSE, you just, okay, back to back you are using temporary registers. Yes or no? Yes or no? Temporary variables. Okay, during TSE we are using temporary variables. Temporary variables you are using, correct? And we are just using it, for example, like this. Okay, T1 is allocated A plus B, then T2 is allocated T1 plus C, and then T3 is allocated T plus E, something like this, and then T4 is allocated T2 plus T3, and so on. Correct? Yes, agree. So you can notice when you are writing 3 address code, and this 3 address code is an intermediate code. This is an intermediate code. And this intermediate, because this is the intermediate code, so you don't have information about actually how many registers are there in the target machine. So you can notice that we are using these temporary variables, okay, and we do not worry about how many registers we have. So we are just using these temporary variables in the 3 address code the compiler is using. Okay, so these temporary variables are used, created by compiler, created by compiler. Now just think about it and tell me, let us assume in your target machine you have 30 registers. Okay, so 32, let us assume you have 30 available registers in your target machine. Okay, so 30 available registers you have in the target machine. And then tell me, okay, okay, and also how do we, and let's assume these two statements. Okay, so total 30 registers we have in the target machine, and let's assume if the maximum number of variables that are used at a time, okay, that are live at a time, that is less than equal to 30, then can I fit them all in the registers? Yes, I can do that. Okay, if, okay, maximum number of variables that are live at the same time, okay, that are used at the same time, if that is less than equal to 30, then I can give them different registers. But now you can notice here in this example, just think about it. In this example, let us assume that when you look at the program, then these variables, okay, so you can notice, let us assume we have only 3 registers in the program. Okay, in the program we have 3 registers. Then what should we do? Let us assume we have 3 registers in the machine code. Assume in machine we have 3 registers. Then what should we do? Then what should we do? We have only 3 registers. So this we can go give to R1, this we can give to R2, this we can give to R3. Where should I store D, E? Can anyone tell me? Where should I store D, E? Then 2 variables are stored in memory. Yes or no? 2 variables stored in memory. Stored in memory, main memory. Okay. And this is called spilling. This is called spilling. Spilling means basically you are storing in the main memory. Okay. So this is the point. So you can notice that this liveness analysis is useful in the register allocation. So how liveness analysis can be used in the register allocation? Is this clear to everyone? So from the liveness analysis, you can very easily find out, okay, basically whether whether you need spelling or not. Is this clear? Anyone has any doubt? So liveness analysis can be used in register allocation. Okay, so this is another application of liveness analysis. Okay, so now let's go to the next point. In this program, can anyone tell me, in this basic block, if this is your basic block, in this basic block, this is your basic block, can you tell me, is there any dead code? Is there any dead code here? Do we have any dead code? Yes, you can notice. Okay, so let us assume, okay, just focus on this. Okay, let us assume this is like, okay, this is the whole program. Let us assume this is the whole program. Okay, let's assume this is the whole program. Okay, so let's assume this is the whole program. Then tell me, do we have dead code? Do we have dead code? And let's assume here you return J. Here you return G. Okay, let's assume you are returning G. Now, because you are returning G, okay, so you can notice, because you are returning G, so this is not a dead code. So this is definitely live. And you are using this F here. This is use. So this is definition. This is definition. And this is use. This is a use. So you can notice this is definition and this is use. Okay, so this statement is definitely live. This statement is also live. But these statements are dead. We are not using them. This definition is also live. This definition is also live. And this definition is also live. Yes or no? Is this clear to everyone? So you can very easily, you can notice, so you can remove them. Okay, so this is the whole point. Okay, which statement is dead? See, this example is already present in the last lecture. Just quickly tell me which statement can be removed from this. So we can remove this statement. You can notice this statement we can remove, because you can notice this definition we are not using anywhere. So this statement we can remove. This also we can remove. Okay, This also we can sorry, this also we can remove. See, you are using this, but this is not used, so I can remove these two. This I can remove, this I can remove. Okay, so these two I can remove. Correct. Okay, so this example is already present in the last lecture. So what statement can be removed? So you can very easily see that, okay, this can be removed and this can be removed. These two statements can be removed. Okay, remember this x is used, so don't remove this, okay, don't remove this, this cannot be removed. And let us assume this is a basic block. Let's assume this is the basic block. If this is the basic block, if this is one of the basic block, can I remove this? This is used, so I cannot remove this. So basically these two statements can be removed. Okay, here can I remove something? Here? Tell me, this statement can I remove? Okay, so very easily you can notice that this definition, see, just think about it and tell me, can I remove x equal to y plus 1? So make the control flow graph so that you can know. Okay, so here actually you can very easily see, if you make the control flow graph for this, then see, if this d is true, then you will not use x, but if d is false, then you will use x. Yes or no? So it's like this, x equal to y plus 1, y equal to 2 into z, and then you can notice that if d, okay, if d is true and if d is false, if d is true, then you will define x again, and if d is false, okay, if d is true, then you will do this. Okay, then then basically you will do this, and let's assume okay, and if else, what will happen? Z equal to 1, z equal to x. So you can notice that if d is false, then you will use x. Okay, if d is false, then you will use x. So this is not dead code. Because if d is false, then you can use x. Definitely this can be removed. You can remove this. There is no problem. Okay, you can very easily remove this. This cannot be removed because if d is false, then you can use this. Then there is a use. Okay, and if d is true, then there is a use here. So this is the point. So only you can remove this z equal to 1. This can be removed. Nothing else can be removed. Okay, so only this can be removed. I hope this is clear. Okay, now in this point, in this graph, what can be removed? So okay, these examples are already present in the last lecture, so you can check there. Okay, so you can just check that, okay, here we cannot remove anything. Okay, because you can notice if d is true, see, if d is you can notice here okay, what I'm saying, if d is false, then you are using x. If d is false. Okay, so if d is false, you are using x, and if d is true, then you are using y. And you can notice that you if what else I can say here, can I remove this z equal to 1? Can anyone tell me, can I remove z equal to 1? This z equal to 1, can I remove this? I cannot remove because you are using this z here. Because this loop is running. You are running this loop. Okay, this loop is running. So because this loop is running, so you are using this z here. Okay, so anyway, this is your dead code. Okay, so now, okay, let us see very important point. Okay, so you can notice here in the last lecture also I told you, okay, for example, if you have a statement like this, let us assume a equal to b plus c. Okay, can you tell me, okay, let us assume here okay, at this, okay, so this is your statement. Okay, let's assume here live, here let's assume e comma f is live. Then can anyone tell me, what can I say at this point of time, what is live? Another statement you have here, let's assume here you are using e plus f. So you can notice that, okay, so see, okay, you can notice that you are using e plus f. Okay, here if you are standing here, then you are using e plus f, you are using e, you are using f. So I can say that e comma f is live. Yes or no? Here, okay, here e plus f is live, correct? So these are the live. These are the live variables. Correct or not? Why these are the live variables? Why these are the live variables? Because tell me why these are the live variables here. Here, when you are standing here, then okay, when you are standing here, this is your control flow. This is your control flow. Okay. Then at this point of time, you can notice here you have A equal to A plus F. So you can notice here at this point of time, you are using E plus F here. So I can say these are live here. And what can I say here? What is live? What can I say here live? See, here E plus F is live. Okay. Now here what is live? Definitely here B is live, C is live because you are using B comma C. E is live, F is live. Okay. So here these are the live. These are the live because you are using B, you are using C, you are using E, you are using F. So these are live. Can anyone tell me what is live here? What is live here? Here what is live? Here you are using A. See, if you are standing here, just before this statement, then you can see that you are using A, you are using all these things. So you are using B, C, E, F. Is this clear? These are live. Tell me, is this point clear to everyone? Anyone has any doubt in this? So let me give you another program. Okay, let's consider this basic block. Just consider this basic block and tell me, okay, what, okay, so some statements I'm giving you. Okay, so let us assume this statement you have A equal to A plus C, F equal to B plus D, return A comma D. Let us assume these are the statements. Okay, so tell me, okay, let us assume initially, as I told you, liveness analysis we do in the bottom up fashion. Okay, back in the reverse order. So tell me what is live. Let us assume here this is the live. This is given. Okay, now find what is live here. Find what is live here. What is live here? Find what is live here, and find what is live here. Tell me what is the answer. So tell me what is the answer. So you can notice we are using A comma D, right? We are using A comma D. So here I can say A comma D are live. Yes or no? Let us assume this is given. This is already given. That this is live. This is already given. That here nothing is live. Okay. Now tell me if you are okay because you are using A comma D. You are using A comma D. So these are live. What about this? Okay. Let us assume this is A comma F. Okay. Let us assume return A comma F. Let us assume return A comma F. Let's assume this is F. Now tell me. Okay. So here A comma F are live because you are using them. Since you are using them, so A comma F are live. Tell me what is live here at this point. Okay, before this. So now you can notice you are not using F. Okay, just think about it. If you are standing here, you are not using F because you are defining F. So I can say B comma D comma A. And what about this? You are using A, right? You are using A. So I can say A comma C comma B comma D. Is this clear? No, see, you are using, see, at this point, you are using A, right? You are using A. Live means what you are using in the future. Okay, just think about it. If you are standing here, okay, if you are standing here, if you are using something here, if you are using something here, if you are using, okay, if you are using B, comma C, then I will say that here live is equal to B, comma C. If you are using in the future, okay, is this clear? You are standing here. If you are using A in the future. See, you are using A in the future. So that is the reason ACBD. These are the live. Is this clear to everyone? I hope this is clear. Okay. So at each instruction, we see whether each variable is live or dead. Remember, at each instruction we will see. And very important thing actually I want to tell you here. Okay, this many students they do not understand this. So that is the reason I am telling you. Just look at this. Live at an instruction means live just before that instruction. So this is a very, very, very important point. See, so far what we have done. Did you notice so far what we have done? So far we were doing this. This is a statement. We were calculating what is live here. See, this is statement. This is statement as we were calculating what is live here and what is live here, and let us assume this is statement as 2. Yes or no? And let us assume this is statement as 0. Are you understanding what I'm saying? I'm saying so far what we have done that these are the statements. We were checking what is live here, what is live here. Between the statements we were checking. Between the statements we were checking what is live. Means before this statement what is live, and after this statement what is live. Before this statement what is live, after this statement what is live. So this is what we have done so far. Yes or no? Before this statement what is live, and after this statement what is live. Agree? Agree? So far this is what we have done. So here you can notice, you can just check here. Okay, before this statement, this is your statement. Before this statement what is live, and after this statement what is live. So this is the point. Correct? Now very important that this terminology live at an instruction means live just before that instruction. Okay, so now this is what we are going to do. Basically what is this you can put here. Basically this is what I want to say. If I give you a program, let us assume this is the program a plus c, and let's assume f is equal to a plus b, and let's assume a is equal to, okay, d plus f. Okay, and then let's assume return, okay, return a comma d. Okay, so let's assume this is your program. Now, okay, in this program, now my question is this. Okay, my question is this. This is S1 statement, this is S2 statement, this is S3 statement, this is S4 statement. My question is, this is my question. Okay, so let's see the question. The question is this: what is live variables at S1? At S1, what are the live variables at S1? What are the live variables at S2? What are the live variables at S3? And what are the live variables at S4? Tell me, what is the answer? Live variables at S1. Remember this point, okay? Live variable at an instruction means live just before that instruction. Just before that instruction. So live at S1 means, what that means? See, live at S1 means this, okay, this is live at S1. Okay, what you write here, this is called live at S1. This is known as live at S1. This is known as live at S2. This is known as live at S3. Here, what is live? This is known as live at S4. Okay, so tell me what is live at S1? Can anyone tell me what is live at S1? What is live at S2? What is live at S3? So very simple, live at S4. So, okay, what is live at S4? So live of S4, I can say, what is live at S4? Live at S4 means what you are using here just before this. Live at S4 means a comma d. See, remember, basically this now we are writing with this statement. This is the only point. Okay, so a comma d. Okay, now tell me what is live at S3? What is live at S3? Means what is live here? Means what is live here? So what is live at S3? So now A is not live. Okay, here A is not live. Here. A is not live because you are reassigning A, because we are redefining A. So A is not live. I can say DF. Only DF are live. Okay. What is live at S2? What is live variables at S2? Now F is not live. Here. Here. F is not live. So what is live? A, B, D. A, B, D are the live. A, B, D are live. Correct? And what is live at S1? What is live at S1? Live at S1 means what is live here? What is live here? That is ACBD. That is ACBD. Is this clear? All these points, are they clear? Live at instruction means live just before that instruction. Okay, clear? Is this clear? Okay, now some rules. Okay, what are the rules? So actually, remember, liveness is checked at every statement. First of all, okay, first of all, you already know that liveness, we check what are the variables live at each statement. This you can see at each instruction. At each instruction, we see what are the variables live and what are the variables dead. Yes or no? At each instruction, we will see what are the variables which are live, what are the variables which are dead. Okay. So if you have this type of statement, okay, then what are live at this? Okay. Can you see at this statement n? What are the live variables at this statement n? At this statement means basically here. What is live here? See what is live here. So what is live here? That is x, y, s, t. That is x, y, s, t. Correct? Yes or no? X, Y, S, T. So this is the point. Okay, so this is important point. Now, some rules we are going to see. Okay, some rules. Let us assume that you already know that what is live here. Okay, so let us assume this is a statement. Okay, so the rule one. Let's assume this is your statement. Okay, and in this statement, you have A equal to B plus C. Okay, and let us assume you already know what is live before. Okay, this is out live. Actually, this is known as out live out, or you can say out live means what is live at here. Okay, means after this, just after this statement, what is live, that is called out live. Means out live of n, let's call this statement n. So what is out live of n? Means just outside this statement, just after this statement, what is live. Let us assume that x comma y are live. Let us assume. Okay, then tell me, what can I say about live at n? What will be live at n? Tell me. What will be live at n? Tell me. If you know x comma y is live, then here answer will be x comma y comma b comma c. X comma y comma b comma c. Clear? Correct? Okay. So this is the rule one. Very simple. Okay. So from this, can you make generalization? Can you make some generalization? Why not A? Because we are not using A. As I told you, use means these are we are using. Again, very important. B comma C we are using. We are not using A. We are defining A. This is definition. This is use. Okay. Is this clear? Is this clear? Is this clear to everyone? Yes, that we will see. Astitva, that we will see. Just wait. Okay, we will see all these things. Don't worry. So first, let me tell me. Okay, just tell me this point. If I have this statement, okay, this rule one. Let me continue this rule one. Okay, we will create a rule one basically. Okay, this is what we are going to create. So we are going to create a rule one. Formally, we are going to create a rule one. Let us assume that this is your outline. Okay, let us assume you know something is out live here. This is your out live of n. Okay, this is something. Okay, you already out. No, this is given. Let us assume something is already known to you. See, this is your statement n. This is the statement n. This is already known to you. Let us assume something is known to you, that what are the variables that are live here. This is already known to you. Is this clear? Let us assume this is already known to you. Now let us assume that you are defining. Okay, this is your defining in n, what you are defining in n, and what you are using in n. These things are known. So these three things are given to you. Can you calculate live at n? If these three things are given to you, then can you calculate? These are given. Remember, these are given. Okay, these are given to you. This is given, this is given, and this is given. If these are given to you, can you calculate live of n? Can you calculate live of n? Let's see who will calculate live of n correct. Some students are saying use plus. Okay, so that is wrong. You can take example. Can I say which statement is correct? Okay, or let me give you some options. Okay, let's see some options. Live at n, that is equal to out live. What is out live of n? Union def union use of n. Is this correct? Is this correct? Which is correct? Okay, so let me give you some options. Okay, for the options, let me give you some options. First option, let me give you use at n, union, out at n. Okay, out live at n. Okay, out at n. Second option, let me give you. Okay, let me give you second option. Use at n, union out at n, minus def of n. Third option, let me give you def of n minus out of n, union use of n. Let me give you option D. Out of n minus def of n, union use of n. Which option is correct? Which option is correct? Which option is going to be correct? Okay, see, okay, just okay, let's play a game. Okay, I am giving you a statement and you tell me whether your answer that you are thinking is correct or not for this statement. Let us assume your statement is this: f is equal to a plus b, and let us assume this is your statement. Let's assume this is your statement n, and let's assume out of n is f comma b, f comma d. Then tell me what will be. Can you tell me what will be live of n? You remember, live of n means what is live here. That is live of n. What is live here? Can you tell me what will be live of n? That will be AD only. That will not include f. That will not include f. HP. Can you see? Is this clear? See, just think about it. You are defining it. You are redefining it. You are only using. So okay. So is your answer correct from this scenario? From this scenario, is your answer correct? So in this statement, you can notice, what I'm using. I'm using a comma d. So use is a comma d. I'm using a comma d, and I'm defining what? I'm defining f. So tell me from this, now tell me what is the answer? What should be the answer from these four options? What should be the answer? These four options. Which option you can remove? Which option you can eliminate? From this scenario, which option you can eliminate? Definitely option A is gone. Okay, option A is definitely gone. Okay, and what option is gone? B is also gone. B is also gone. Can you see B is also gone or not? No, B is not gone, right? So far, B is not gone. From this example, B is not gone, correct? From this example, B is not gone. Yes or no? B is not gone. A is gone, but B is not gone. C is gone. Can you see C is gone? No, C is also not gone. Okay. Okay, C is also not gone, I think. Def minus this. C is also not gone. Okay, let me give you another example. Consider this statement. Node n is this. Okay, A equal to A plus B. And let us assume out of n is this. I'm giving you out of n. Out of n is A comma F. Now tell me what is live of n. I want correct answer. Tell me what is live of n. You can very easily see. Okay, what is live of n? So you can very easily see live of n will be what? Means what is live here? Live of n means what is live here. So A is live, B is live, and F is live. ABF, correct? I think everyone has given correct answer. So live of n is ABF. Okay. So you can very easily notice that. Okay, here. What is def of n? Can anyone tell me what is def of n? What is def of n? That is only A. And what is use of n? What is use of n? That is A comma B. Def of n is A. Okay, correct. So now tell me what should be the correct definition. Now tell me the answer. Okay, I hope you. Okay, now can you give me the answer? Here, what is the answer? Answer is option D. Option D is correct. Here, option D is correct. Why option D is correct? Let me tell you. Okay, let me explain this. Why option D is correct? Now you can very easily see option D is correct. Why option D is correct? Because this is what you do. See, this is what you will do. So this is a rule. I can say this is a rule. If you have a statement, let's assume this is a statement. This is a statement N. Let us assume that use of N is given to you. Okay. And out of N you already know. So out of N is given. So these are given. These are known to you. Let us assume these are known to you. Out of N, what we are defining in N and what we are using in N. What we are using in N. Now just tell me this point. So now I can calculate life of N very easily. What I will do? Very simply. First of all, from out of N, I will remove the def of N. Yes or no? From the out of N, I will remove the def of N. And then I will take union with use of N. Then I will take union with use of N. Is this clear to everyone? Union with use of N. Is this clear? So you can notice here, from out of N, first I will remove this definition of N. So from this A comma F, I will remove this A. Then I will take union with A comma B. So actually what I'm doing this. From this A comma F, I am removing A. And then I'm taking union. Then I'm taking union with A comma B. To how many students this is clear? This rule is clear. To how many students? Now can you very easily see? If you know what is live after a statement, then can you tell me what is live at a statement? Anyone has any doubt in this? If you know what is live after a statement, then can you tell me what is live at a statement? Any statement I give you, you can do that. Correct? Yes or no? So finally, this is the final point. Okay, statement N. So you can very easily calculate live of N. So this is our rule. So this is a rule that live of N is equal to out of N minus def of N union use of N. Okay, I hope this rule is clear. I hope this rule is clear. Okay. So this is the rule. Okay. So let's see. So you can handle one statement, individual statement you can handle. Okay. So we will complete this class. Okay. We will complete the topic, then we will stop. Okay. If you need to go, see, if anyone needs to go, you can go, because the lecture will be uploaded on the YouTube. Okay. So you can watch the lecture on the YouTube also, on the Go Classes YouTube channel, you can watch it. Okay. And if you can stay, you can stay. Okay. So that we can discuss. Okay. So that you can ask your doubts, because many new things, many good things are coming, and then we will solve the gate questions. Okay. So this is the point. Now let's see. Okay, for this give me, okay, find at each instruction what is live. At each instruction what is live? Tell me. Find live variables at each instruction. Find live variables at each instruction. At each instruction. Find live variables at each instruction. So tell me. Let's call S1, let's call S2, let's call S3, let's call S4, let's call S5, let's call S6. These are the statements. Okay. So find live variables at each instruction. So the answer is very, very, very simple. Just tell me, okay, I'm asking you, you tell me the answer. Okay. So tell me, what are the live variables here? What are the live variables at this statement? What do I mean at this statement? What do I mean by at this statement? I mean what I'm using here or in future. What I'm using here or in future. So live at an statement means, remember this point, remember, live at an statement. live at statement, live at statement n, live at statement n means live just before, live just before statement n. Okay, means okay, means live at or in future, live at an or in future, live at used at an or in future, means used at an or in future. Okay, so these are the points. Okay, so you can notice here live at S6. What are the live at S6? You are using Y3 because at S6 we are using Y3. Here what are we using? Now you can notice, okay, just remove, okay, apply the algorithm, please apply the rule. Are you applying the rule? Apply the rule so that you can handle the complicated questions. Apply this rule: out minus def union use. So now this is the out. Yes or no? This is the out of S5. Out of S5 is yes or no? Out of S5 is Y3. You can notice here. Now this is the out of S5. Means what is here? What is live here? That is this Y3. So from Y3 you remove Y3 and then you union with Y2 X3. So finally you will get Y2 X3. Are you applying the rule or no? See, are you getting the rule? So you can notice what is, if I ask you what is out of S5, what is out of S5? Tell me. Out of S5 is in of S6. I can say out of S5 is this, and this is actually in of S6. Okay, at any statement means this is your statement, this is your statement. Okay, what is live here? That is called in of n, and what is live here? That is called out of n. In of n is same as what? Tell me. Tell me. In of n is same as live of n. This is same as live at n. Correct? Is this point clear? Anyone has any doubt? Very simple. So what I can say here you can notice, if I ask you what is in of S6, so that is in of S6 is means what is here? In of S6 means here. Okay, so tell me what is live at S4? Live at S4 means out of S4 minus definition of S4 union X1 union X2. So that will be X1, X2, X3. And what is live here? Okay, remove X3 and then X1 union X2. And here what is live? X1. And here what is live? Tell me, here what is live? Nothing. Here what is live? Nothing. Is this clear? Anyone has any doubt? Is this clear to everyone? Or anyone has any doubt? So remember, okay, if you have some statements, let's take one more example we will take. Okay, so how are you calculating so fast? By this rule. By this rule. See this rule. You have this rule. You have a statement. This rule I am using, nothing else. This rule we have already seen. The proof we have already seen. The proof of this rule we have already seen. A statement of n. If this is the statement n. Now, what is live here? That is out live. What is live here? Okay, that is out live. This is called out of n. This is called in of n. And here we call live of n. Live of n is same as in of n. Both are same. Both are same. Okay, live of n is equal to in of n. And you already know live of n, that is equal to what? This formula we have already seen. What is that? Out of n minus def of n union use of n. This formula I am using. Okay. So this is the point. Why we go backwards, I will explain. Okay, why we go backwards? Can we go forward? Can anyone tell me, can we go forward? I told you in the last class, live variable analysis is backward analysis. This live variable analysis, this is backward analysis. We are going for backward. Can you notice we are going backward? Yes or no? In this example also we are going backward. We are going backward, right? Yes or no? We are going backward. Can we go forward? I will explain to you. Yes, we can go forward also, but it will take more time. Okay, let me explain. It will take more time. In this example, let me explain that it will take more time. It will take many iterations actually. Okay, if you go forward, okay, see, okay, this question, let me ask you. This is the question. Okay, in liveness analysis, we are going backward. In liveness analysis, we go backwards. We go backwards, correct? Or I can say liveness analysis is backward analysis. We go backwards. But can we go forward? Okay. First of all, why? Why we go backward? And can we go forward? Why not go forward? Okay. Let me explain. Let me explain. Yes, you can go forward, but the answer is efficiency. The answer is efficiency. So the answer is this. Yes, you can go forward. Yes, we can do liveness analysis in forward manner. In any manner, we can go forward. We can go forward in liveness analysis. But it is inefficient. It is very inefficient. Backward analysis is efficient. Let me answer why. Okay, so the same example I will take. Okay, let me take the same example that is here, so you can notice this is same example. Let me take. Okay, just okay, so this is same example I will. Okay, so the same example I'm going to take. Okay, so can you tell me? Okay, initially nothing is live, right? Yes or no? Initially nothing is live. So now you notice what is going to happen. Okay, so initially nothing is live. Okay, let's assume you are going forward. Let's assume you are going forward. Initially nothing is live. Initially nothing is live. Nothing is live. Okay, now let's go forward. Okay, here, can you tell me at this point of time, can you tell me at this point of time at S1, can you tell me something? Is something, can you tell me? Can I say something? Okay, don't go at S2, S3. Don't look at S2, S3. Okay, just tell me. Okay, by looking at S1, can you tell me something? Can something become live? Can some variable become live just by looking at S1? Just look at S1. Can you say no? No variable will become live. Okay, so this is okay. Now go to S2. Go to S2. Can I say something will become live? Can I say something will become live? Yes, X1 will become live. X1 will become live. So okay, so let me tell you, this is the initial setup. So this is initially. Okay, so let me say this is initial. Okay, now let's see. Now let's see. This is the initially. Now what will happen? First iteration. Now I am telling you first iteration. First iteration. Okay, so here you can say that X1 is live. Now you have this information that X1 is live. Now you have this information that X1 is live. What can you say about X? What can I say about S3? What can I say about S3? I can say X1, X2 are live. X1, X2. I can say they are live. Okay. And what can I say about S4? What can I say about S4? X1, X2 are live. again x1 x2 are live. What can I say about s5? What can I say about s5? y2 x3 are live. And what can I say about s6? S6 y3 is live. This is the first iteration. Do you agree? This is the first iteration. Okay, this is the first iteration. Agree? Now let's, okay, is this the final answer? Just tell me this point. Is this the final answer? Is this your final answer? No. So let's do the second iteration. Okay, let's do the second iteration. So let me do the second iteration. Now what will happen? Second iteration. Let's do second iteration. Again go forward. Again go forward. Tell me. Now can you notice something interesting will happen? Tell me, what can you say about live at S1? What can you say about live at S1? Live at S1 means what? See, live at S1 means out of S1 minus def of S1 union use of S1. Okay, so what is out of S1? Tell me what is out of S1? That is X1 minus def of S1, that is X1, union use of X1, that is 5. So finally 5. So in the second iteration also this will be 5. 5, correct? Is it clear? In the second iteration also this will be 5. Okay, tell me what about live of S2? What about live of S2? What about live of S2? That means out of S2 minus def of S2 union use of S2. Okay, so let's see. So you can notice out of S2 minus def of S2 union use of S2. Okay, so tell me what is out of S2? What is out of S2? Just tell me this point. What is out of S2? Out of S2 is X1, X2. Out of S2 is X1, X2. Out of S2. Out of S2 means what is here? Out of S2 means what is here? What is here? What is live here? Live here is X1, X2. Live here is X1, X2. So out of S2 is X1, X2. X1, X2 minus def of S1. Minus, sorry, def of S2. Minus def of S2 means X2. Def of X2 means X2. Union use of S2. Use of S2 is X1. So finally what you will get? Finally what you will get? That is X1. So finally in the second iteration, here you will get X1. Okay, X1, again you will only get X1. Same, now similarly can you do? What can I say about S3? What can I say about S3 now? S3 will be what? That will be X1 union X2. That will be X1 union X2. What can you say about S4? What can you say about S4? S4. Tell me, what can you say about S4? S4 means Y2 X3 minus Y2. So this will be X1 X2 X3. This will be now X1 X2 X3. Okay. Now tell me, what can you say about S5? What can you say about S5? What can you say? So again, you can notice, what can you say? Y3 cancel. So this will be Y2 X3. This will be Y2 X3. So, okay. So in the second iteration, this will be your answer. Okay. In the second iteration, is it different from the first iteration? This answer, is it different from the first iteration? Is it different from the first iteration? Yes, this is different. You can notice the difference. You can notice the difference. This additional thing is coming. This additional thing was not here. Here we did not have. So the second iteration is different. If I do the third iteration, will the answer change? Can I do the third iteration? In the third iteration, will answer change? Let's do the third iteration. In the third iteration, again, you can check. Okay, so this will be same. Okay, so you can notice, and this will be same because you can notice, okay, X1, X2. Okay, so this will be same. Next, again, you can notice that X3. Okay, so X1, X2. So now it will not change. So second iteration is equal to third iteration. So now you can stop. Second iteration is same as third iteration. Now you can stop. So you can notice second iteration result is same as third iteration result. So stop. So final, you have final answer. So your answer is so you can see. Can you see forward analysis is inefficient? Yes or no? So forward analysis is inefficient. But you can do. Okay, so if you got everything so far, then you can do anything. All the questions you can do. Tell me. All the concepts, everything is over from this liveness analysis. Tell me, anyone has any doubt or is it clear? Like, can you tell me, is it clear or no? Anyone has any doubt? Small doubt, big doubt, doesn't matter. Anyone has any doubt? Yes, we will take Astitwa, don't worry, we will take loop question. Okay, what if we have loop? I will tell you. Okay, first, so far is it clear? So this is the liveness analysis. Okay, so you, okay, can you understand this image? Can you understand this image? So you can notice here we are referencing F. Okay, so can you notice this image? Can you understand? Okay, so here F comma E will be there, and then F comma A comma B comma C. I will explain, don't worry. HP, it is coming. It is coming in the future. Okay, one by one, slide by slide, just understand all these things that you are asking are coming in the future. Okay, loop, out, how to calculate out, all these things are coming. So is this picture clear to everyone? This picture, can you understand? Okay, now let's see. Is this picture clear? Just look at these pictures and tell me, are they clear to everyone? So ABC, this is live here. Now here you are defining, so this will be removed. Now AB, now okay. So this picture is also clear. Very easy, because you are defining A. So now here this is not live. Here at this point of time, A is not live. Okay. Okay. So what we are referencing, use means reference. See, some authors use, okay, use means reference. Use also means reference. Okay. So for example, what are you referencing here? Are you referencing or defining? For example, in x plus, okay. So tell me, in this statement, x equal to 3, in this statement, tell me, what is the use? What are the variables that you are using? And what are the variables you are defining? Tell me. Use means read and def means write. So here we are not using anything, but here we are defining x. Okay. Use means ref. Okay, reference. Okay, so like this you can. Okay, so you can check. In this we are not defining anything. In this we are defining also and reading also. So I hope these points are clear. Okay. So like this you can do. Okay, so this formula we have already seen, correct? Yes or no? Live of n. Live of n is equal to in live. In live means live of n, because see, if you have this statement, okay, if this is your statement, n, then remember in live means at, okay, here what is live? Okay, here what is live? This is called in live. Okay, this is called in live. And here what is, okay, just after this is called out live. And what is this live of n? Again, because this is important, many students, they make mistake here. So that is the reason I'm asking again, what is live of n? What is live of n? Live of n simply means what is in live. Correct? Because live at statement, it automatically means just before it. Yes or no? Just before it. Correct? Means just before it, what is live, and just after it, what is live. So this formula we have already seen. The proof we have already seen. Okay. Now, okay. So all these things you can just check it out. Okay. So how to calculate out? Okay, this is an interesting point. Someone is asking. So we have now seen, okay, you can very easily calculate. Okay, this you can calculate by looking at the statement. If you look at the statement, you can do this, you can find this. These things you can find. Okay, if you know this, then you can find this. If you know this, then you can find this. But how can you find outline? This is the question. How can you find outline? Can anyone tell me? Can anyone tell me how can you find outline? Means it's like this. If you have some statement, then how can you find what is live just after this? Okay. So for example, if you have a statement, let's assume this is a statement as. Okay. My question is, let us assume these are given to you. Now these are known to you. Okay. Now these are known to you. These are known to you. In of every statement. Okay. You know in of, in live of every statement. Every statement. You know in live of every statement. Let's assume you know this. Every statement. Okay. You know in live of every statement. There is a statement S2. There is a statement S3 and so on. Okay. And let's assume this is a basic block. This is a basic block. Let's assume this is a basic block. Okay. So tell me if this is a basic block. Okay. What it means? This is a basic block. What it means? I'm saying this is a basic block. What it means? It means how many successor of S1? How many successor of S1? Tell me. This is a basic block. How many successor of S1? S1 has only one successor. How many successor of S2? How many successor of S2? One. How many successor of S3? How many successor of S3? Not known. Very good. Not known. Anything. Okay. How many? Because basic block you already know. See, this is a basic block. If this is a basic block, okay. If this is a basic block, I told you in basic block, if this is your statement S1, this is your statement S2, S3, S4. Now you can notice here the control can come from anywhere. Okay. The control can come from anywhere. Here the control can go to anywhere. So remember, successor of S2 will be only S3. Remember, successor of S2 will be only S3. But successor of S4 can be many. Yes or no? Can be many. Successor of S4 can be many. Correct or not? Can be many. Okay. Successor of S1 will be only S2. You can notice successor of S1 will be only S2. Is this point clear? Now my question is this. If you know in of, okay, can you find out? Okay, what is out of S1? What is out of S1? You know, these are these you know. So this is what I want to find. Okay, just find what is out of, what is out live of S1. What is the answer? Tell me. Tell me what will be the answer. What will be out live of S1? Out live of S1 means in of S2. Yes or no? Out live of S1 means in of S2. Very simple. So the answer is very simple. Out live means, see, okay, this is very simple. Okay, what is out live of S1? What is here? This is in of S2. Yes or no? This is in of S2. So in of S2 is basically out live of S1. Is this clear? Okay, is this clear? Now, okay, interesting thing. What is out live of S4? What is out here? Okay, what is out live here? What is out live of S3? Basically, this is my question. What is out live of S3? So this is a basic block. In this basic block, you have S1, you have S2, you have S3. My question is, what is out live of S3? If you know, in of everything you know, in of everything you know, in of everything known. Okay, what is known? In of everything you know. Now let me tell you. Okay, so remember this is a basic block. Remember this is a basic block. So there can be another basic block. There can be another basic block. There can be something like this. Okay, there can be something like this. Correct? There can be something like this. So what is out live of S3? Anyone want to try? Anyone want to try? Like, can you give me some idea? I just want your idea. In live of S3. No. Intersection of in. Union of in, actually, okay, take this example, see, okay, consider this example. Let us assume that you have this graph, okay, a equal to b plus c, okay, and let's assume here you have if, okay, here a is greater than b, okay, if then if a is greater than b, then basically if this is true, then you will go here, okay, what you will do, you will do b equal to a plus b, and if this is false, then you will go here, and what you will do, you will do a equal to b plus c. Okay, now this is interesting. Okay, now tell me, okay, now tell me, okay, so this is the exit block, let's assume this is the exit block. Okay, now on this question, on this let's try. So tell me, here you have nothing, okay, 5 5, okay, nothing is live here. Can anyone tell me what is live here at this point? What is live? Okay, so this is the question. What is live here? Tell me what is live here, what is live here. So you can very easily notice here what is live. Here live is a comma d, so here a comma d is live, and here live is b comma c, b comma c is live. Now tell me what is out live of this statement. Let's call it s1, let's call it s2, let's call it s3, let's call it s4. What is out live of s2? Just tell me this point. This is my question. What is out live of s2? What is out live of s2? What is out live of s2 means what is out live here, here what is live, here what is live, here what is live, what is out live of s2? Tell me, quickly tell me. The answer is a b c d. Yes or no? A b c d. Because you can notice what is live here. Tell me, if you are standing here, if you are standing here, okay, just think about it and tell me. Okay, just think about it. This is a very simple point. If you are standing here, what is live for you? What is being used? What is being used? If you are standing here, what is being used? See, here a comma d is being used, here b comma c is being used. If you are standing here, then what is live? A comma d is live, b comma c is live. So finally I can say out live of s2 is equal to a b c d. Do you agree or not? Anyone? Very intuitive, very intuitive. If you are standing here, then what is live? If you are standing here, then what is live? So here a comma d is live, here b comma c is live. So finally I can say if you are standing here, then you are using a variable here, d variable here, b variable here, c variable here. So if you are standing here, then you are using correct, correct. So if you are standing here, then you are using. Okay. Okay. So I hope this point is clear. So now can you tell me what is the answer? What should be the answer here? What should be the answer here? What should be the outlive of S3? Let's assume this statement is S4. Let's assume this statement is S5. Let's assume this statement is S6. Now tell me what is outlive of S3. Tell me what is outlive of S3. Tell me what is that? That is union of in, yes or no? So that is in of S4 union in of S5 union in of S6. Correct? Correct? Or I can say the same thing. I can say that in means what is live at S4. Basically I can say that what is live at S4 union what is live at S5 union what is live at S6. Isn't it correct? To how many people this concept is clear? Everyone has given correct answer. So that is the reason I am asking. Is this clear to everyone? So now can you find out? Okay. So now you can find everything. Out live of S2 you can find. Okay. What is out live of S1? Tell me. Find out what is out live of S1. You have what is out live of S1. First you find, okay, out live of S1 is simply in of S2. That is simply in of S2. And what is in of S2? What is, how will you find? Can you tell me how will you find in of S2? Do we have a formula? Do we have formula? How will you find in of S2? In of S2. How will you find in of S2? Very simple. From out of S2, what is in of S2? See, in of S2, that is simply out of S2 minus def of S2 minus def of S2. What else? What else? Tell me what else. Quickly tell me what else. Union use of S2. Isn't it correct? So finally, I can say ABCD minus what is you are defining, and then union use. So again ABCD. So finally here also answer will be ABCD. Yes or no? Yes or no? No one is giving answer now. Tell me. Got it? And what is in of S1? What is in of S1? Give me the answer. In of S1. In of S1. What is that? That is out of S1 minus. Okay. So that is out of S1 minus what you are defining on S1 union use of S1. Okay. So out of S1, you already know out of S1 ABCD minus A. So, okay, BCD. So the answer will be BCD. Okay. So here answer will be BCD. Okay. So this will be answer will be BCD. Okay. Is this clear? The answer will be BCD. Correct, Rasi? Yes or no? So like this you can do. So finally, how can you find outlier? Okay, so this was our topic. Our topic was how to find outlier. Okay, so how to find outlier? Now can you give me the formula for outlier? Can you give me the formula for outlier? So finally, what formula can you find out for outlier? So I can say outlier of any statement. What is that? Outlier of any statement. What is that? That is union of in live of successor of n. Successor of n. Yes or no? So find all the successor of n. Okay, so that is union of, basically this is union of in live of all successors of n. Okay, in a straight line code, what you can say? In a straight line code, this statement we have, but if you have a basic block, then what can you say? If you have like this S1, S2, S3, S1, S2, S3, S4. If you have this, then what can you say? If you have this straight line code, means if you have this straight line code, then what can you say? Now out of S1 will be, because only one successor. If you see how many successor of S1, so that will be only S2. This is the successor of S1. What is the successor of S2? The successor of S2 will be S3. So out of S1 will be what? Out of S1 will be S2. Sorry, out of S1 will be what? Tell me, out of S1 will be what? That will be in of S1. That means live of S1. Sorry, S2, 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 live of S2. Similarly, out of S2 will be in of S3, means live at S3. Okay. Similarly, out of S3 will be in of S4, means live of S4. What is out of S4? That is union of successor of S4. That is union of in of successor of S4. Okay, so this is the formal analysis. Okay, I hope this is clear. I hope. Okay, hopefully this is clear. Anyone? How many people can say that everything is clear to you? So okay, backward analysis we do mostly. Okay, as I told you. So we do the backward analysis. Okay. So, okay, this program is already given in the last lecture. Okay, so I am going quickly. Okay, you just check it out. This is given. Let us assume this is given. This is given. Okay, so these are live here. So tell me here what will be live. Here what will be live? Quickly tell me. Quickly. Okay, quickly tell me what will be live here. Quickly. That will be BDE. That will be BDE. Here, tell me quickly what will be live here. Okay, quickly tell me what will be live here. What will be live here? Okay, that will be, okay, see, okay, that will be, okay, what will be live here? Very simply you can find out. Okay, all you have to do, BDE minus D union A. Okay, so finally what will be live here? That will be, okay, BDE minus D, so that will be BEA. Correct? Yes or no? BEA. Correct or not? Agree? Yes, very good. Everyone has given correct answer. Very good, very good. Okay, what will be live here? Means what will be live here? I can say what will be live here. What will be live here? Because what is live here, that automatically means what is live here. So what is live here? E will be removed and ABD. Again ABD. Okay. So next again ABD. Okay. Next, what is live here? That will be ABD minus D. Okay. So AB. So that will be AB. Okay. Next, what is live here? Means basically what is live at this statement? Live at second statement. What is live at second statement? That will be only B. That will be AB. That will be AB. Okay. That will be AB. Next, what will be live at the first statement? What is live at the first statement? That is B. That is okay. So this is how you can do liveness analysis. In the backward, only one pass you need. Yes or no? Can you notice in the backward, we only need, okay, if you do backwards, then how many iteration you need? Backwards, how many iteration you need? Tell me. Backwards, how many iteration? Only one iteration is needed. So in this liveness analysis on a basic block, okay, basically, okay, on a basic block, I can say that backwards, if you go backwards, then only one iteration. You only need one iteration. Okay, and forward, if you go forward, then okay, more than, okay, then many, maybe may need many iterations. May need many iterations. Okay, so this is the point. Okay, so this is the, okay, no, okay, remember, this is liveness analysis. This is just analysis. This is only analysis. This is just analysis. Okay, this is dead code elimination. Now you can eliminate dead code. So tell me, okay, what this tells you? Now you can eliminate the dead code. See, this tells you that after this statement, F is not live. After this statement, F is not live. See, this, what this tells you, just think about it. What this tells you that after this statement, F is not live. Means after this statement, F is not used. After this statement, F is not used. So I can remove this statement. So this is called dead code elimination. So you can remove this statement. This statement is gone. Okay. Now this tells you, okay, what this tells you, tell me what this means, that this D is used. This D is definitely used. So don't remove it. Okay. Now, similarly here you can notice this means, what this means? This means that C is not live. This means C is not live here. C is not live here. What it means? It means this C is not used anywhere. This C is not used anywhere. So you can remove it. Okay, like this you can do. See, okay, now you can notice one thing. In the last lecture also I told you, if you do like this, okay, first you do liveness analysis, then you do dead code elimination, then you will have to do multiple times. Again you do liveness analysis. Again on this program, finally on this program, again you do liveness analysis, then you will get this. Okay, liveness analysis, we are doing liveness analysis, finally you will get this. Then again you do dead code elimination, then you will get this. You will get this. Again you do liveness analysis. Okay, again you do liveness analysis, then you will get this. This is what you are going to get. Okay, then again you do dead code elimination, then finally you will get this. So can you notice that? Okay, just tell me this point. Just tell me this point. If you do liveness analysis, first you do liveness analysis, okay, and then you do dead code elimination. Is this efficient? Is this efficient? This is liveness analysis. Okay, is this efficient? This is not efficient. This is not efficient. So what is efficient? Efficient is simply there is a combined algorithm. There is a combined algorithm. There is a combined algorithm. Basically, do together, do simultaneously. This liveness analysis, okay, plus dead code elimination simultaneously. Do them simultaneously. Do them simultaneously. Okay, so if you do them simultaneously, this is what is going to happen. Okay, you can notice simultaneously I am doing it. Okay, so here b comma d is live. Okay, so what it means? It means f is not live. It means I can remove this. Okay, so simultaneously I am doing. Okay, just remove it. Okay, so this is gone. Now again, what is okay? So tell me what will be live. Okay, so this d is used. Okay, this d is used. Okay, now you can notice that finally I will have a comma b. It means this is also gone. It means this e is not used. Okay, so this is also gone. Okay, this is also gone. Now again, what you have? So this d is also gone because this d is not live. This means d is not live. Here d is not live. It means this d is not used. Okay, so this d is also gone. Then again this c is also gone. Can you see this combined algorithm is very simple? This is more efficient. This combined algorithm, can you see? Yes or no? So we have a combined algorithm where liveness analysis and dead code elimination, both of them we do together. If we do them together, then you can very easily do this. Okay, okay. Now loops, how to handle loops? Okay, so this is the question, how to handle loops. Okay, so this is what we are going to see now. So first of all, this formula we have seen. Anyone has any doubt in this formula? This we have already seen. This outlive is equal to union of in live of successor. Okay, yes or no? This formula we have already seen. So there is any doubt in this formula? Anyone has any doubt in this formula? So this we have already seen, correct? So okay, so now let's see. So finally we have these two formula. Okay, finally we have these two formula. Now in these two formula, actually you can merge. Can you see that? Can you replace this value with this value? Yes or no? You can replace this outlive of n. You can replace this value with this. Okay, so finally you can write like this also. Remember, this means, this automatically means in live of n. So you can merge them. Basically, instead of this, you can directly use this. You can directly use this. Okay, so just put this value here. Then what you will get? Then you will get this formula. This formula you are going to. Okay. Now let's see. How can we handle? So if you have a basic block, if you have, okay, without loop, what you need to, okay, so far what we have seen, this is what we have seen so far. Liveness analysis on without loops, liveness analysis on CFG without loops, yes or no? On CFG without loops, so far we did not have loops. Okay, so we have seen so far liveness analysis on CFG without loops. Okay, for this without loop, actually when you have CFG without loops, on this what you can do, you can, okay, one backward pass, one backward iteration or pass is enough. Okay, remember, one backward pass is enough. If there is no loop, then only one backward pass is enough. Okay, just go backward and one pass is enough, one iteration is enough. This we have already seen. Now what will happen if you have, let us assume you have this type of loop. So this is loop, yes or no? This is a loop. Can you see this is a loop? This is a loop, yes or no? Can you see this is a loop? Now tell me, is this analysis correct? Are they correct? Are these answers correct? Just think about it and tell me, are these answers correct? Let's see how to handle loops. Okay, how to handle loops. This is what we are going to see now. Okay, so tell me, first of all, okay, just apply your intuition, and tell me, is this answer correct? Okay, don't worry about the algorithm, don't worry about anything, just tell me, is this answer correct? It seems correct, right? It seems correct, but is there any mistake or is it correct? Do we have any mistake here or is it correct? It looks like this is correct, but I don't know. Like, okay, you tell me. Is there any mistake here? Let me tell you, there is mistake here. What is the mistake? Let's see whether you can find it out or not. Okay, what is the mistake? Just think about it and tell. See, here Z, that is fine, right? This is correct, right? Just okay, tell me one by one. Okay, step by step, I'm asking. Is this correct? Is this correct? Yes, this is correct, right? Yes or no? This is correct. Okay, so there is no problem here. So this is correct. Okay. Now, tell me, okay, at this statement, can I say y comma z? This is also correct, right? Yes or no? This is also correct. So there is no problem here. This is also correct. Correct? Yes or no? Because you are using z. See, this is okay. You can notice you y union z. Okay, just apply the formula. Just apply the formula. This is also correct. Okay. Is this correct? Is this correct? X, Y, Z. See, you are referencing X, so X is coming, and Y, Z, so this is also correct. This is also correct. Okay. And can you see this is also correct? X comma here. If you are standing here, what are we using? If you are standing here, then we are defining Z, but we are using X, Y. If you are standing here, then we are defining Z, but we are using X, Y. So this is also correct. And here we are defining X, Y. So this is so seems like correct. Is there any mistake? Let me tell you, there is a mistake, but can you find it out? There is a mistake here. And the mistake is because of this loop. You are not considering this loop. You are not considering this loop. Just consider this loop. There is a mistake here. Because of this loop, some issue is coming. Yes, very good. X is missing here. Here X is missing. See, just think about it. If you are standing here, can you see that you are using X? Can you see you are using X? If you are standing here, can you see you are using X? You are using X. So if you are standing here, can you see X is missing? X is missing, can you see? Is this point correct? Is this clear to everyone? There is a mistake. This is not correct because X is missing. So X is missing. The correct answer is this. This X was missing. This X was missing. So how to handle these loops? Now let me tell you, very easy, extremely easy. Okay, all you have to do, can anyone tell me what we have to do? How to handle loops? Very easy, just multiple iterations. Okay, basically multiple iterations. That's it. This is the answer. Multiple iterations. Just keep iterating. See, I told you, if you don't have loops, then single pass is enough. If there is no loop, okay, if there is without loops, if there is no loop, then single pass is enough. If you have loop, then multiple iterations, then keep doing the iterations. Now, for the example, this, okay, let's take this example. The same question we will take. Okay, let me take the same question and let me try. Okay, so, okay, so this question, let me take. Okay, yeah. So taking this question, okay. So let me take. Initially, this is the initial setup. Okay, this is the initial setup. Just see this. Okay, very simple. Very simple. Initially, this is the initial setup, correct? Yes or no? So this is the initial setup. Now let me write. This is initially. Okay, so this is initial. Initially, this is happening. Okay, now we are going to go one by one. We are going to go. Okay, but go in backwards. Okay, go backwards. See, okay, multiple iterations, but going backwards. Always do backward because that will okay. So, but okay, but go backwards. But go backwards. Why? Can anyone tell me why? Do we have to go backwards or we are doing this for efficiency? But okay, multiple iterations, but go backwards. So that less number of iterations you have to do. So that less number of iterations you have to do. Okay, so this is the point. Okay, let's do this on this question we will do. So this is the question. So this is the initial setup. Initially this is the point. Now go backwards. Tell me, in the first iteration what will happen? In the first iteration, just apply these formulas. Okay, all you have to do, apply these formulas that you have seen. Okay, just apply these formulas. For which formula? For example, outlive of n, this is union of in live of successor of n. Okay, this formula you have to use. And also in live of n, what is that? That is equal to, in live of n is equal to what? That is equal to outlive of n, outlive of n minus def of n union use of n. Just apply these formulas, nothing else. Very simple, extremely simple, let me promise you. Okay, just try this. Okay, so here go backwards. Okay, always go backwards. So first iteration. Okay, so this will be z, correct? Go backwards. I am going backwards. Okay, go backwards. Okay, so this is z. Okay, tell me, in the first iteration, I am going in the first iteration. So what should I write here? Tell me, what should I write here? Okay, I am going backwards. I am going backwards. What should I write here? What should I write here? I should write y comma z, correct? I should write y comma z. Very good. Okay, what should I write here? What should I write here? I should write x comma y comma z, correct? Yes or no? Very good, very good. Okay, very good. Okay, what should I write here? What should I write here? I am going in backward direction. What should I write here? See, okay, x comma y, x comma y I should write, correct? Yes, very good, very good. Okay, what should I write here? This is also correct. So this is the first iteration. This is the result of first iteration. This is the result of first iteration. Okay, let's see the second iteration. Now we will do the second iteration. Okay, let's do the second iteration. So in the second iteration, okay, at this statement, is anyone changing? Let's call it as 1, let's call it as 2, let's call it as 3, let's call it as 4, let's call it as 5. Here, is anything changing here? Okay, go backwards, go backwards. Is anything changing here? No, nothing is changing. Okay, nothing. Okay, okay, tell me about S4. Tell me about S4 now. Okay, is anything changing here? Is anything changing here? Is anything changing here? Okay, yes, because what are the successor of S4? Apply the formula, please apply the formula. These formulas we have already seen, we have already proven. These formulas you apply. Why are you not applying these formulas? Okay, what are the successor of S4? Just tell me this point. What are the successor of S4? So successor of S4, what is that? That is S5, S2, S2, S5. So what is out? What is outlive of S4? Outlive of S4 is union. Okay, outlive of S4 is in of S2, or I can say, okay, I can say live of S2 union live of S5. What is live of S2? Live of S2 is x comma y union live of S5, which is z. So finally x, y, z. Isn't it simple? Is there anyone who can tell me, is this simple or not? Isn't it simple? I hope you are finding this interesting. Like this chapter, this code optimization chapter is very interesting if you understand it. See, many students, they don't understand it. Okay, they just like by heart. Okay, most of the things they don't understand the basics of it. They don't understand it deeply. Okay, but if you understand it with basics without by hearting, okay, then you can find it very interesting. Like this seems like very interesting topic. Okay, is there anyone who is enjoying this? Like, okay, all these one by one we are handling all these things. First we handled statements. First we saw how to handle statement. Then we saw how to handle basic block. Then we saw how to handle control flow graph without loop. Now we are looking at control flow graph with loops. Are you finding it interesting or not? Is anyone here who is understanding all the points that I am teaching? Okay, so okay, so tell me here. Okay, so this is also very simple. So this will be xyz. Okay, is anything will change here? Will anything change here? Okay, here, okay, as S3. At S3, anything will change? No, nothing will change. Okay, nothing will change. At S4, at S2, nothing will change. Okay, so you can notice this is the point. Okay, so this is the second iteration. In the third iteration, also nothing will change. Let me tell you, in the third iteration, you can try the third iteration, nothing will change. In the third iteration, nothing will change. Correct? So the third iteration is also same. If you do the third iteration, then also answer is same. So finally, I can say that third iteration and second iteration result are same. Yes or no? Yes or no? Second iteration result is same as third iteration result. So stop. So this is your answer. So final answer is this. Yes or no? If you do this, can you see there is no scope of mistake? You will not do any mistake. Okay, yes or no? We are not doing any mistake. There is no mistake because what is the successor of S4? Look at the successor of S4. The successor of S4 is S2, S5. Just apply the formula, nothing else. Okay. So this is the algorithm that we have done. Basically, this algorithm means basically do iteratively. Okay. Backward analysis, do iteratively. Backward, go backward. Okay. Remember, go backward analysis. Go backward. Backward analysis, multiple iterations, as long as now, okay, until nothing changes, this is your algorithm. Yes or no? Isn't it simple, this algorithm? Okay, so this is, we have already done. Okay, so this is the point. Okay, this is your gate exam question. Let's solve it. Okay, and let me tell you one more thing. So far, most of the students, they know the answer of this question, but they have not done it the way it should be have done. Okay, now we are going to do it. Okay, now we are going to solve it, and very easy. Okay, just look at this gate 2015 question. Okay, this has a loop. Does it have a loop? This control flow graph, does it have a loop? Yes, there is a loop here. There is a loop here. Because of this loop, we may need multiple iterations. There is a loop here. If there is no loop, then what will be the answer? Okay, see, if there is no loop, then this question is very easy. Okay, let's solve this question without loop. Okay, let's solve. Okay, let's change this question. Let me change this question. Let me just remove this loop. Okay, this possibility of loop, let me remove, and let's solve this question now. If there is no loop, okay, if this loop is not given, now let's solve this question. Okay, let's remove all these things. Okay, let's remove all these things. Yes, okay, tell me. So this is the definition. This is nothing but the definition that we have seen. This is the definition that we have already seen. This is just a definition. Okay, can anyone solve it? Okay, tell me. Now go backwards. How many iterations we need? Tell me. How many iterations we need? There is no loop. Okay, because there is no loop, so you can see there is no loop. Because there is no loop, one backward iteration is enough. One backward pass is enough. One backward pass enough. One backward pass enough. Okay, so tell me, what is live here? What is live at 4? What is live at 4? That is V comma R. Okay, what is live at 3? What is live at 3? Tell me. SUVR. SUVR, correct? SUVR, correct or no? What is live 2? Live of 2. Tell me live of 2. Live of 2. Okay, so you can notice that is VR minus V. So basically VR minus V and RU. RU, yes or no? RU, correct? Yes or no? Live of 2. Is this correct? Live of 2. Live of 2 is RU. Because with this V will be removed. This V will be removed. Okay, RU. Okay, now tell me, okay, this statement. Okay, so this statement, what is the live of this statement? Just tell me the live of this statement. Live of means live at this statement. That will be what? Okay, let me call this. Okay, let me give names. Let me give names here. Let me call this S1. Let me call this S2. Let me call this S3. Okay, let's handle S1 here. Okay, so let's handle S3 here. So tell me, what is live of S3? What is the formula? What is live of S3? What is the formula? The formula is outlive. Outlive is what? Okay, see, outlive. The formula is this: outlive of S3 minus def of S3. Okay, outlive of S3 minus def of S3 union use of S3. Union use of S3. What is outlive of S3? Okay, what is outlive of S3? This is a union of successor. This is a union of, this is actually, okay, what is this? Okay, outlive of S3. Can anyone tell me? That is in of 2, in of 3. Okay, that means in of 2 union in of 3. Okay, minus def of S3. Correct? Isn't it correct? And union use of S3. Actually, you don't have to write these formulas in the GATE exam. Can you notice in the GATE exam, you can very easily do, okay, how can you do very easily? See, SURV, okay, so this is SURV minus U, okay, so SURV minus U, so this will be, okay, so final answer will be what? So the final answer will be what? SURV minus U, SURV minus U. So this will be the answer, correct? Yes or no? SRV. Many students have given correct answer SRV. What is live of S2? Tell me what is live of S2? Live of S2. What is that? SRV is already there. SRV minus S PQ. So RV PQ. PQ RV. PQ RV. PQ RV. Okay. So that will be PQ RV. And what is live of S1? What is live of S1? Live of S1. So remove P. Okay. So QRV. So that will be QRV. Okay. So everyone has given correct answer so far. So can you notice this is very easy. So if there is no loop, one backward pass is enough. Isn't it simple? This question, if this comes in the GATE exam without loop, then this is very simple, right? Now you will see that this question is also very simple. Okay. This multiple pass we have. Okay. Basically, we need multiple pass, nothing else. Okay. This question is very simple, but we need multiple pass. Okay. So let's make multiple pass here. Okay. Because of, okay, let's make multiple pass. Here we need multiple pass basically. Okay. Because you have loop. Okay. Since you have a loop, so multiple pass are needed. Okay. So let's start. Okay. So again, let's start from the bottom. Okay. From the bottom. What is the, okay. So tell me what is, again, this is S1, S2, S3. You already know this is S1, S2, S3. Okay. So let's call this statement S1. Let's call this statement S2. Let's call this statement S3. Okay. So tell me, okay, backward pass. Okay. First iteration. Initially, everything is 5. Yes or no? Initially, you can notice. Okay. Initially, at every node, at every statement, you have 5. At every statement, okay, live is equal to 5. Okay. Now, tell me, now first iteration. What will happen in the first iteration? Go backwards. Go backwards. So tell me, what is live of 4? Quickly tell me, what is live of 4? Live of 4. Okay, means what is live here? So what is live here? Live of 4. So here live of 4 is V comma R. This is the live of 4. Okay, VR. Okay. Now you already know VR. Now tell me what is the live of 2? What is live of 2? What is live of 2? You already know VR is live of 4. Then what is V of 2? That live of 2. So that will be V will be removed. So this will be RU. RU. Yes or no? And what will be live of okay. So what will be live of 3? 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 That will be what? Okay, so that will be VRSU. Correct? Okay, correct. Very good. Okay, now tell me what is live of S1? What is live of S1? Live of or you can say live of S3 actually. Okay, just calculate live of S3. Live of S3 because go backwards. Go backwards. So live of S3, what is that? Okay, so what is the live of S3? So you can notice that. Okay, this is SURV minus U. So that will be SURV minus U. So that will be SRV. This will be SRV. What is S2? What is live of S2? Live of S2, that will be PQRV. And what is live of S1? Live of S1, what is that? Live of S1, what is that? That is P will be removed. Basically, P will be removed. So QRV. Okay, QRV, correct. Okay, so this is the first iteration. Now let's make second iteration. Now what will happen in the second iteration? Just tell me this point. Okay. Can anyone tell me where the changes will happen in the second iteration? Okay, which is the part where you should look at? In the second iteration, where you should look at? Where you should look at? In the second iteration, where you should look at? You should look at this 4, because 4 is a multiple successor. You should look at 4. Why? You should look at 4 because 4 has multiple successor. Actually, you should look at everything, okay? But 4 is important because 4 has multiple successor. What are the successor of 4? What are the successor of 4? Successor of 4 is S1, comma. Successor of 4 is S1. Sorry. 4 has, okay, sorry. So 4 has only one successor. 4 only has one successor. Which has more than one successor? Is there anything which has more than one successor? Do we have more than one successor anywhere? 1. Yes, 1 has more than one successor. Yes. Okay. So 1 has more than, yes. So successor of 1, that will be 2,3. Okay. And anyway, okay. So let's do one more iteration. Tell me what will be 4. Tell me, will there be any changes here? Okay. In the second iteration, just tell me, will there be any changes here? Answer is very simple. Out means, okay, what is S1? You know what is, okay. So QRV minus Q, okay. So basically RV, there will be no changes. Yes or no? There will be no changes. Yes or no? Oh, Mr. O, see, Mr. O, see, this is like this. So successor of 4 is actually S1. Successor of 4 is actually S1. Is this clear? So there will be no changes here. Okay. So here there will be no changes. Okay. Is there any changes in 3? Will there be any changes in 3? Okay. So you can notice in 3, will there be any changes? Okay. So you have RV. Okay. So there will be again no changes. Is there any changes in 2? Is there any changes in 2? No, there is no change. Is there any changes anywhere? Okay. It looks like, do we have any changes anywhere? Okay. Let's see. Okay. Will there be any changes anywhere? It looks like there will be no changes. It looks like there will be no changes from 1 to 4. Okay, so let us check it out. Okay, so let us check it out. S3, what can you say about S3? S3 again will be VRSU minus U. So that is also no changes. There is no changes actually. Yes or no? In the second iteration also there is no changes. So the first iteration is same as second iteration. You can just check it out. The first iteration is same as second iteration. Okay, because you have VR and here S1 has QRV. So okay, so you are removing Q. Okay, and RV. Okay, so there is no change here because there is no change here. So there is no change here. There is no change here, and so there is no change. So there is no change anywhere. Actually, let me tell you, if there was any change at 4, then there would have been changes. Because there is no change at 4, so that is the reason there is no changes. So second iteration is same as fourth iteration. Sorry, first iteration. Second iteration and first iteration both are same. So what I can say, tell me, what I can say. So stop. Okay. So you can notice first iteration, second iteration result are same. Result same as second iteration result. So stop. Okay, now the answer you can give. Okay, so what the question is saying? The question is saying the variables which are live at basic block 3 and in this statement, 2,3. What are the, basically what is the intersection of 2,3? So finally, what is the answer? Live at 2,3. Live at 2 and 3. Live at 2 and 3. What are the variables which are live at 2 and 3? That are r comma u, r comma u. Okay, so these are the variables which are live at r comma u. So answer will be option C. Okay, is this clear? So you can notice here there is only one iteration is needed. Only one iteration is needed. Okay, only one iteration is needed. Tell me one more thing, very interesting thing I want to ask you. Okay, if you don't do second iteration, okay, for this question, there is backward age from 1 to 4. From 1 to 4. There is no, from 4 to 1, there is age. From 4 to 1, there is age. We have taken it. We have taken it in the consideration. You can just check it. Sir, we took union between S2 and S3. No, we did not take union. We applied the formula. We applied the formula. We removed S. From this, we removed this S, and then we took union with P comma Q. For the answer, we took intersection because the question is saying what are the live at both here and here. What are the variables which are live here and here? So the answer will be R comma U. We took intersection R comma U. Anyone has any doubt? Is this question clear? This GATE exam question, is this clear? The complete analysis we have done. We have solved this question in the correct manner. Many students, they solve it wrongly actually. Okay, they solve it, but they solve it wrongly. Okay, tell me one interesting thing. If you have this question and these are the options, can I stop without doing second iteration? Like, okay, don't do second iteration. Can I stop without doing second iteration? Can I stop without doing second iteration? Actually, I can't, but after the first iteration, I can remove option A, option D. After the first iteration, I can remove option A, option D. Why? Tell me why. Because this is a very important note. This will help you. This is a big note. Once you, okay, in any iteration, once you find out that something is live at some point, in the next iteration, will it go away? Tell me. Will it go away? No, it will never go away. So this is the very interesting point that, okay, it stays. Okay, as soon as you find out that variable x is live at statement s, then in future iterations, x will remain live. X will remain live at S. Is this point clear? So for example, after the first iteration, you know that here RU is live, here RUSV is live. It means this RU will always remain live here. This RU, these four will always remain live here. So they will remain live here. They will remain live here. So definitely after the first iteration, you can easily say that definitely RU will be live here and here, but maybe something more. So whenever you do iteration, what, okay, the live variables are added. They are not removed. Yes or no? So basically in every iteration, live variables at a statement, okay, in every iteration, live variables at a statement may increase, may added, never removed. Okay, may be added, but never removed, or stay same. Okay, or stay as it is, may be added. Okay, so this is the point. Okay, I hope all these concepts are. This is a GATE 2021 question. This is a, okay, just tell me the answer. Can anyone tell me the answer? This is a GATE 2021 question. The question is saying that you have basic block in which you have S1 followed by S2. You have a basic block in which you have S1 followed by S2. The question is asking what is out of S1. The question is asking what is out of S1. Can anyone tell me what is the answer? Okay, option A, yes or no? Isn't it simple? Option A, out of S1 will be, okay, will be in of S2. So the answer will be option A. Answer will be option A, because here, see how many successor of S1, because this is a basic block. See, okay, if they ask you, okay, remember this point you already know that out live of S, that is nothing but union of in live of successors of S. I don't know, maybe I don't know, 1 more 2 mark, I don't, but this is the GATE 2021 question. So we have done GATE 2021 question, we have done GATE 2015 question. Okay, this GATE 2015 question also we have done. Okay, so this question also we have done. Both these GATE exam questions, you can just check it out. Okay, can we do some variations? Okay, let's do some variations. Okay, let me make some variation here in this question. Let me make some variation. Let me give you some more options. Okay, some more options let me give you. So let us assume, can I, okay, if you have this option, would it be correct if I write like this? Out of S1 is equal to in of S2 union use of S2. Is this correct? In of S2 union use of S2. Is this correct? Yes, this is also correct. Why this is also correct? Why this is also correct? Because in of S2 already includes use of S2. Yes or no? In of S2, is a superset of use of S2, isn't it? Okay, so these are some observations. Okay, some observations. Can you make some observations? Let me make some observations. First observation. Okay, the first observation. Can you see that in of S, this will always be superset of use of S. In of S will always be superset of use of S. Correct or not? Yes or no? Yes, correct. That's it. So this is first observation. Second observation you can notice. Okay, I think like this you can make some observations. Okay, and this is not an observation, but this, okay, in of S is same as live of S, live at S. Okay, this you already know. So these are these are not observations, but actually these are the final conclusion, I can say. Okay, final conclusion. Third, in of S, that is equal to what? That is out of S minus def of S union use of S. Okay, so these are some formulas. Fourth formula, out of S is equal to union of in of successor of S. Okay, and you can combine all these formulas. So finally, can you combine these two? Then finally I can say live of S is equal to, okay, union of in of successor of S minus def of S union use of S. So these are the some formulas. Okay, these are some observations. Okay, so this is our topic. Okay, so okay, so the time, okay, is 12:32, 33. How out of S1 is equal to, because this is a superset. See this is correct. Ananya, is this clear? This is clear. In of S is always superset of use of S. This is clear, right? Yes or no? If this is clear, then you can just check it out. This is clear. If this is clear, then you can just see that this is a superset of this. Both this is actually in of S2. This is actually in of S2. Okay. So this is your live variable analysis. Okay. So we have done everything, and I promise you, no question can be asked. Like, they will not ask you any question outside our slides. Okay. These slides, these notes I have taken from Ullman book, from Stanford University, and from some other universities. Okay. So like this is the like I have taken everything. Okay, in these slides. Okay. So both the GATE exam question we have done. Okay. We have seen how to find out live variables at any point, at any statement. Okay. So whether you have context free grammar with loop, okay, context free grammar with loop, without loop, anything. Okay. So if anyone has any doubt in the liveness analysis, what we have seen so far, if anyone has any doubt in this, you can ask. Okay. So I will take one more class. Okay. Actually, it is not needed. You can read these slides. You can read actually. Okay. No more class is needed. But maybe I can take one class tomorrow. Okay. So one more class I will take tomorrow. Okay. And in that class, I will discuss some more GATE exam question I will discuss. Okay. A very short class, 1 hour class we will take. Okay. Only 1 or 2 hour class. Tomorrow I will take. Okay. In this class, we will take some more GATE questions, some more practice questions we will take in this class. Okay. Some like standard book questions also I will take. Okay. In this class. Okay. So if anyone has any doubt right now, you can ask. And the class is over. So I will only take the doubts. Okay. Thank you. What is your name? Okay. Your username is O. Okay. Anyone has any doubt, you can ask. Yes, Astitwa, kindly raise your hand and kindly ask your doubt. Kindly raise your hand. Hello. Yes, Astitwa.
So hello, sir.
Yes, hello.
So actually, I want to ask, like, so I am facing issues in undecidability and decidability. So it's like
We will
sometimes questions came, so I
see.
got confused in that. Like, there is no such permanent statements which I can decide. Like, so just for example, like, I am giving some test series and some questions. So one question came that there is a language LM for the Turing machine which is regular. So I thought that we can decide whether a language is regular or not. So I ticked it that it is decidable, but it was undecidable after that. Like, there is any such rule by which we can decide?
So, okay. See, having any such rule, that itself is undecidable. Okay. So first of all, okay. And let me tell you actually, okay, I will take one class of decidability, undecidability, a long class. Like, okay, today we have this 6 hour class, like, right? Yes or no? In this 6 hour class, I have taken many doubts. Okay. Any doubt that students are asking, I took it. Okay. So this is the point. Okay. Let me tell you that I will take one class I will take on this decidability and decidability. But in that class, I will cover every variation. I promise you that every single variation I will cover. Like many questions, almost 100 questions I will take. Okay, all the GATE exam question and everything. Okay, so there will be a 5 or 6 hour class. You can join that class first of all. Okay, but in that class actually, because okay, now GATE exam is coming. Okay, and in that class I will not prove anything. That's the point. Okay, I will not prove anything, but okay, I will answer, I will solve many questions, many all the variations, everything I will solve. Okay, in that class. If you want the proof, okay, if you want to study decidability and decidability, okay, for example, if you have 4 days, you can take the TOC course. Okay, in the Go classes TOC course you can take. In Go classes TOC course you can take. In this TOC course, you can ask all the Go classes students, you can ask them. In this TOC course, actually, I have taught decidability for almost 8 classes. Decidability with proof. This decidability chapter, okay, with proof I have taught, okay, the proof of halting problem, reduction, okay, everything, okay. Okay, so with proof. So this I have taught, and there are, I think there are 7 or 8 lectures, and each lecture has 2 or 3 hours. So basically, if you want to understand this, if you really want to understand this, okay, you want to understand, you want to solve the questions, okay, you want to master this, then okay, what you can do, you can take this TOC course and you can study the decidability. Okay, so almost 7 or 8 lectures you will see there. There I have the proof of halting problem, the proof of reductions, some reductions, okay, some 3 or 4 reductions are there, many variations are there, Rice theorem 1, Rice theorem 2, okay. So all the variations that are possible I have taken them, okay. So if you want to understand, if you really want to understand, but if you only want to solve the questions, if you only want to solve the gate questions, okay, many students actually they don't want to understand concepts, they just want to solve questions, okay. If you want to solve questions, then I will take one 5 or 6 hour session, okay. So there will be a 5 or 6 hour session on this topic, okay. In this session I will not cover any proof, I will just cover how to like basically without proof I will cover everything, okay, in this session, okay. Without proof I am going to cover everything, okay. So you can for understanding you can join the TOC course of Go classes, okay. And for solving the gate exam question you can join this session, okay.
So
Just tell me.
so one more, like, so it's a very like simple doubt, sir. Like I have like in computer networks, like there are questions when came like when the size when the size will reach 16 kb. So like we are counting like 2 4 8, then it goes to 14, like then it goes to 12, then it goes to 14. So we just stop before 16, like before 16 we just stop a step before. Sir, why
If you
so?
have
Like,
if you have doubts in CN, then you should ask Sachin. Okay, so you can send a message to Sachin and he will answer it. Okay, because our Go classes CN faculty is Sachin, so he knows computer network very nicely. Okay, he will answer your doubt.
so one last, sir, it's a very like uh, how should I say, so it's a very like very foolish doubt, sir. Like while drawing automata, so like any type of automata came, like once I was doing a question, a mod 10 automata came for the binary numbers. So I was
Okay.
drawing, I used that some simple mathematics, but I got always like, yeah, either less or one more or one less states. Like it was never like equivalent, sir. Any like short trick, any trick for that?
Actually, this automata, this DFA design also, see, many students, they what they do, they first create NFA, then they create DFA, then they minimize. Okay. So then they minimize. Okay. But this is very inefficient method. Okay. This is very inefficient. Okay. So this is a foolish method actually. Okay. What you should do, you should practice directly. You can create minimized DFA in 99% of the cases. Okay. Like,
Sir, like sometimes very long cases came.
no, in the gate exam, they will not give you those dumb questions. Okay, those big 10 states. Okay, these type of dumb questions will not come in the gate exam. In the gate exam, they you are confusing the gate exam questions with the test series questions. Okay, you might have seen many questions in the test series. Okay, but in the gate exam, they will not give you big DFA. If you have to create 10 state DFA, if you have to create 10 state DFA, then it means it will not come in the gate exam. Okay, maybe some in the gate exam. Either if you have to create the DFA, then it will have very less states, 4 5 states, 6 states. Okay, or if the answer is like 20 state, 30 state, then definitely there is a trick. Maybe Mahil-Nerod theorem. Okay, you can watch on the Go classes YouTube channel. You can watch the Mahil-Nerod lecture. Okay, this Mahil-Nerod lecture you want. Okay, in this lecture I have solved some question where without creating the DFA, you can find out the number of state in the DFA. Okay, with proof. Okay, so this is the correct method. So this Mahil-Nerod lecture you can find out on the YouTube. This is already uploaded. Okay, so just watch this lecture and your doubt will be clear. If any doubt, okay, afterwards also if there is any doubt, you can ask in the TOC class. Right now I am teaching compiler design. Okay, so when we do the revision of TOC, at that time you can ask your doubt. Okay, so please right now please stick to compiler design. Okay, you can join the Go classes Telegram group, and in that group I will announce when the TOC revision class doubt classes will be available. Okay, so at that time you can ask your TOC doubts.
So sorry, sir. Like in the algorithm, sir. Like you have once told that I don't know the algorithm name. Like in which algorithm, Kruskal's and Prim's, like we don't check for the cycle.
Yes, in the Prim's algorithm, cycle can never occur. Basically, this Prim's algorithm, if you see this Prim's algo, okay, in this Prim's algo, the idea of Prim's algorithm is like this: that algorithm, in this algorithm, cycle can never occur. So you don't need any cycle checking algorithm. So basically, in this Prim algorithm, inside this Prim's algorithm, you never have to check for a cycle, because cycle can never occur. Okay, in Kruskal cycle can occur. So that is the reason you have to check for cycles. Okay, in Kruskal, okay, in this Kruskal algorithm, cycle can occur, cycle may occur, cycle may occur. So you have to you need some cycle checking algorithm. So basically need cycle checking algorithm. Okay, correct. Cycle checking algorithm.
Okay,
But
sir.
in Prim's algorithm, cycle can never occur. Cycle can never occur. So there is no need of cycle checking algorithm. And why is that? Okay, so no need of cycle checking algorithm. See, this is one misconception among many students. They think that okay, cycle checking algorithm is needed, but no. In Prim's algorithm, we don't need any cycle checking algorithm. Why? What is the why? Why in Prim's algorithm? Why cycle can never occur? Why cycle can never occur? Can anyone tell me? Because we are adding one vertex. Okay, just think about it. Okay, see, you have a vertex. Just think about it. You have a vertex. Okay, you are starting from this vertex v1. Okay, now you have many vertex here. Okay, you have many vertices here. So now what you are doing? You are adding one vertex to this. Okay, now what in the next step? What you are doing? You are adding new vertex to this. Just think about it. If you have a graph, if you have a graph, let's assume you have a graph. You have a graph in this tree. If you add one vertex, if you add a new vertex to this tree, then can cycle come? Can cycle come? If you add new vertex to this tree, you have a tree. In this tree, you have a tree. In this tree, if you add new vertex, cycle can never come.
Yes,
So
sir.
in Prim's algorithm, every time we are adding one vertex, okay, every time, in every iteration, this is what we are doing. This is the idea, or I can say proof of Prim's algorithm. This is the idea. Idea is this. Initially, you start with vertex. Okay, so this is your initial. From here, you are restarting. Okay, and these are the remaining vertices like B, C, okay, D, E. These are the remaining vertices. Now, what will happen? Now you will find I can say okay the closest vertex. Okay, then you will add it. Now in the next, this is the step one. Now, what is the step two? Okay, in the step two, this will happen. In the step two, let us assume you are adding A and you have added B. Now you notice that here you have C, here you have D, here you have. So every time you are adding one vertex, this is your step two. This is your step two. And in the next step, what you will do? You will add new vertex. So every time you are adding new vertex to a tree. Okay, so in a tree, if you add a new vertex every time, then a cycle can never come. Yes or no?
Yes, sir.
So that is the point. In Kruskal, why cycle can come? In Kruskal, cycle can come. Why? Because in Kruskal, what is happening? You are adding edge. Just think about it and tell me, okay, in Prim's algorithm, this is what you are doing. In Prim's, you are adding one vertex to a tree. Okay. In Prim's, basically adding new vertex new vertex to a tree. In Kruskal, what we do? In Kruskal, what we do? In Kruskal,
So,
we add new edge
yes,
to a
yes, sir.
forest. Adding new edge to a forest. New edge to a forest. So now what can happen? For example, here you have this is your tree. Let's assume this is your tree. Okay. In this tree, if you add new vertex, then cycle can never come because this cycle can never come. Okay. So cycle never come. Never possible. Okay, now here you can notice if you have a like for example, let us assume this is your forest. Okay, this is your forest, this is your forest, and now you are adding this vertex A. This vertex A you are adding. Then sorry, this edge you are adding. Sorry, this edge you are adding. Now if you are adding this edge, then cycle can come. So cycle is possible because you are adding new edge to the forest. So cycle is possible. So cycle possible may occur. So you have to remove this cycle basically. Okay.
Okay, sir.
Can we score full marks in compiler design? Definitely, 100%. Compiler design is very scoring subject actually. Okay. And from this code optimization, I guarantee one question will come. Okay, 2 or 3 marks will come from the code optimization because this code optimization was added last year. This is a newly added chapter. Okay. And last year from the code optimization in set 2, 3 marks came. 3 marks from code optimization. This year also, I think 2 or 3 marks will come. For dynamic programming, class will be taken by Sachin. Okay. For algorithm data structure, these classes will be taken by Sachin.
So
Yes.
So this is the last one, sir. So like in cache, while solving inode questions, like it asks answers in KB, sometimes in MB. So you give the answer in MB. So I used to calculate it with the calculator, and it came like 1.0 something.
Astitva, you are asking all the doubts which are not related to the compiler design. Okay, so right now this lecture will go in the compiler design playlist. So okay, just message me here. Okay, this is my WhatsApp number 946. This is my WhatsApp number. You can just send me a message. If anyone has any doubt, you can send me message here. Okay, 946@93096. Okay, so actually this inode we have taught in the operating system. In a way, there we have taught this inode and this concept we have already taught in the operating system. So okay, so there you can understand this very easily. But if you have any doubt, you can say any doubt regarding anything. Okay, at any point of time. Regarding the gate exam or okay, any technical doubt, you can send me a message on this. This is my WhatsApp number.
Okay, sir. Thank you,
And
sir.
if you want to join the future revision classes, the future doubt classes, if you want to join, then you can join the Telegram group of Go classes. Okay, so on the Telegram group of Go classes, all the future announcements, all the announcements and all the study material is uploaded on this Telegram group. Okay, of Go classes. The link you can, if you want link, then you can send me a message on this number. Okay, just send me a message. I will send you the link of the Telegram group. Okay, on this group we will do the announcement, we will put the study material, everything. Okay, okay, anyone has any doubt, any other technical doubt, any technical doubt? Mr. O, can you send me your doubt on WhatsApp? Okay, because I have to click this and this link I have to click and I have to check it out. Okay, so you can send me your doubt on the WhatsApp. Okay, study material, this slide, these slides will be available on the Telegram group today. Okay, I will upload these slides there. Okay, okay, thank you everyone, bye.